However, the bottom halves of the sleeve bearings must be rolled into position before the rotating assembly can be lowered into position. Make sure that the bearing locating lugs are in their proper location in the bearing housings. Now coat the bearings and shaft bearing journals with a light coat of turbine lubricating oil. The rotating assembly can now be lowered into the bearings. Remember to lower it very carefully, paying special attention to the position of the oil rings. After the rotating assembly is in position, the workman measures the clearance between the nozzle ring and the blading of the first rotor. The clearance should be approximately 1/16 of an inch. Check your manufacturer's manual if you have any questions. The clearance between the seal sleeves and the bearing cases must also be checked to make sure it meets manufacturer's specifications. The workman is shown measuring the radial clearance between the seal sleeve and the mating surface of the bearing case. Now he is checking the axial clearance between the sleeve and the case. The next step will be to check the bearing to journal clearance on both bearing journals. The strips of plastigauge should be placed just inside the ends of the bearing half, as shown here. Then, while lifting the oil rings out of the way with one hand, the workman lowers the top half of the bearing into place on the shaft. Do not slide the bearing down the shaft, since this would destroy the effectiveness of the plastigauge. It's important that you lower the bearing half onto the shaft very carefully. Make sure the top half of the bearing is aligned with the bottom half. Repeat the procedure for the opposite bearing. Now the bearing caps are lowered into position on top of the bearing liners. Make sure that the locating lugs in the top halves of the liners fit in the corresponding notches in the caps. The workman is pointing out the location of these lugs and notches. Once the bearing caps are properly aligned, they should be tightened securely in place. The entire process is now reversed. We must remove the bearing cap and liner so we can check the width of the plastigauge. To do this, the workman removes the cap screws and lifts the bearing cap just enough to enable him to snap the bearing liner out of the cap. He then removes the caps. The next step is very important. Lift the oil rings up as shown, then lift the bearing liner off the shaft very carefully and remove it. Don't slide the liner out, because doing so would damage the plastigauge stuck to the liner and destroy the accuracy of the measurement you are to obtain. Using the plastigauge scale, the workman measures the width of the plastigauge and determines the actual clearance between the bearing liner and the shaft bearing journal. He checks the figures against the manufacturer's specifications. If they are satisfactory, he removes the plastigauge. The workman then replaces the bearing liner and cap and tightens the cap screws securely. It's considered good practice to check the shaft at this point to see if it is binding in any way due to improper bearing installation. This may be done by turning the shaft manually, as the workman is now doing. Now, the outboard bearing on the turbine is a different story. After replacing the bearing liner, he leaves the bearing cap off. This is necessary because the governor hood on this particular turbine cannot be installed when the outboard bearing cap is in place. A cloth is placed over the open bearing housing to protect it from dirt until the cap is replaced later in the reassembly process. The next step of our job is to replace the carbon packing rings in the housings on each side of the turbine rotor. First, we must check to ensure that the inside diameter of the assembled rings are within manufacturer's specifications. If they are not, it may be necessary to obtain new rings. The proper procedure for installation of the rings is to begin with the carbon ring nearest the rotor. Be very careful not to damage the rings as you assemble them. It's very important that the ring stops on the garter spring be in position as shown here. They must fit in the slots provided for them in the carbon ring and in the packing housing itself. These stops prevent the rings from turning during operation of the turbine. Now that the carbon ring packing has been replaced, we can reinstall the cover on the turbine case. First, however, the workman applies sealant to the joint between the case and cover, as shown here. Check with your instructor to find out the type of sealing compound in use for this purpose at your plant. He will also demonstrate the proper methods for applying it. Once the sealant is in place, a shackle is fastened to the eye bolt in the turbine case cover, and the cover is lowered to a position just above the lower half of the case. With the cover in this position, it is a simple matter to align the two with dowel pins. After the cover and case are aligned, the workman lowers the cover the remainder of the way and secures it in place with the cap screws. Be sure that you use the crossover method in tightening the screws to prevent cocking or tilting of the cover. The packing case covers are next to be installed during the reassembly process. As with the turbine cover, a sealing compound must be used to prevent steam leakage through the joint between the cover and the turbine case. Be very careful to ensure that none of the sealing compound gets inside the packing chambers. The cap screws on the vertical joint of the packing covers should be snugged first, as the workman is now doing. Once the vertical joint cap screws are snug, the horizontal joint screws should be tightened down. Then tighten the vertical joint cap screws. This procedure for reinstalling the packing case covers provides the best seal and ensures proper alignment. The next task is to replace the hand trip lever and torsion spring. Then reinstall the snap retainer ring. The overspeed trip valve is placed in the valve body, as shown here. Make sure it is properly seated in the valve seat. Don't forget to apply the proper sealant to the joint between the valve body and the cover. After the sealant has been evenly applied, install the cover and secure it. The auxiliary resetting lever is next to be reinstalled. Slide it into its bracket with the return spring, as shown. The locking devices must then be installed to hold the auxiliary resetting lever in place. The valve stem connection block should be screwed onto the stem and returned to its original position. Check the position by measuring like this. Compare it against the measurement taken earlier in the course during disassembly. Now insert the guide blocks into the resetting lever and hold them in place with your hand. If you don't, they may fall out as you install the resetting lever. Lower the resetting lever over the valve stem as shown. With the resetting lever in position, slip the guide blocks onto the slots in the connection block. Once you've tried this for yourself, you'll find that it's not nearly as complicated as it sounds. Now align the hole in the stationary end of the resetting lever with the hole in the anchor bracket. When they are aligned, tap the anchor pin into the hole. Remember to lock the anchor pin in place with the set screw, as the workman is now doing. Next, slide the bushing, lower spring seat, spring, and upper spring seat. Once they are in place, screw the lock nut onto the stem and tighten it down securely. With the overspeed trip valve closed, measure the clearance between the resetting lever and the auxiliary resetting lever. This clearance should be about 1/32 of an inch, with the resetting lever in the tripped position. The workman now raises the resetting lever very slowly, watching the spring very closely. The spring should begin to compress just before the resetting lever has been raised high enough to latch onto the hand trip lever. You should also feel additional resistance from the spring at this point. The resistance is caused by the shoulder on the top of the valve coming in contact with the upper valve seat in the cover. The seal created by the shoulder and the seat is designed to prevent steam from escaping between the valve stem and guide during operation of the turbine. After you feel the resistance, continue raising the resetting lever until the knife edges of the resetting lever and the hand trip lever latch. Check to be sure the knife edges are engaged properly. Next, turn the shaft until the weighted end of the trip pin is positioned directly over the trip plunger. Then measure the gap between the pin and the plunger, as the workman is doing here. The clearance should be about 1/16 of an inch. If the gap between the trip pin and plunger is not correct, you can adjust the position of the plunger with this jack screw in the end of the hand trip lever. To test the action of the overspeed trip system, press down on the opposite end of the trip pin. as shown here. The trip pin is forced down against the trip plunger, which pushes down against the jack screw in the hand trip lever. The hand trip lever pivots, releasing the knife edge of the resetting lever. The spring on the resetting lever then pulls the valve closed, showing that the overspeed trip linkage is operating correctly. Since the assembly is working correctly, reattach the spring to the resetting lever and to the valve cover. That completes the reassembly of the overspeed trip assembly. The first step in the reassembly of the constant speed governor valve is to make sure the valve is securely pinned to the stem. Then our workman slides the valve into the valve body and positions it carefully in the valve seat. Remember that the faces of the valve and seat have been lapped, and their fit should be nearly perfect. Since this is true, be extremely careful not to damage the contacting surfaces through rough handling or other abuse. Before replacing the cover, apply the specified sealing compound to the joint between the cover and the body of the valve assembly. Then slide the cover over the stem. Position it carefully and firmly against the sealant on the body joint and bolt it up. Check your manufacturer's manual to find out what type of packing should be used. Then pack the packing box in the cover of the constant speed governor valve assembly. With the packing in place, screw the follower into the packing box tightly enough to seat the packing firmly. Then back the follower off until it's only finger tight. Replace the jam nut in its original position on the constant speed governor valve stem as shown. Then measure from the face of the jam nut to the end of the stem to ensure that the position is the same as that you recorded during disassembly. Now screw the connection onto the stem and seat it against the jam nut. Secure it in position by tightening the connection against the jam nut. The governor hood is replaced on the constant speed governor by simply sliding it over the stem and positioning it in the groove in the bearing housing. As we mentioned earlier in the course, the outboard bearing cap could not be replaced until the governor hood was reinstalled. Now that the hood is back in place, the bearing cap can be installed and tightened down. The grommet seal, already in place on the spindle, should now be snapped into the hood. The only unassembled part of the constant speed governor is the linkage. The first step in putting it back together is to replace the pin in the governor valve stem connection. Then slide the governor lever over the pin in the valve stem connection as shown. Now the workman aligns the hole in the governor lever with the hole in the fulcrum bracket. When they are in line, he installs the pin. We must now measure the valve travel, which the workman is doing here. He is pushing the governor valve stem in as far as it will go until the valve seats. Then he measures from the back of the connection to the face of the follower. Once he obtains the measurement, he writes it down. Before taking his second measurement, he aligns the hole in the governor lever with the hole in the spindle connection and installs the pin. The linkage is now complete. The second measurement is taken from the same points as the first one a few moments ago, from the back of the connection on the governor valve stem to the face of the follower. Write the figures from this measurement above those you obtained a few moments ago. The workman then subtracts the first measurement, which was smaller, from the larger measurement just taken. The difference between the two measurements must meet manufacturer's specifications. In many cases, it will be equal to 1/8 the diameter of the valve. Just a few miscellaneous parts remain to be reinstalled, and our reassembly process will be complete. This lubricator must be replaced on the spindle connection. The speed changer assembly also remains to be reinstalled, as shown here. As you can see, it is connected to the end of the governor lever and to the outboard bearing housing. Some turbines will not be equipped with a speed changer. The sentinel valve must also be replaced on the turbine case, as the workman is now doing. Reinstall the coupling half on the turbine shaft according to the procedures used at your plant. The coupling should also be checked for runout with a dial indicator. Don't forget to reinstall the strainer in the steam inlet body. Now that reassembly is complete, the turbine is ready to be sent back to its unit. Your plant will have a location tag which you should attach to the turbine. The tag will supply the required information to route the turbine back to its unit. In most cases, you will also attach a lubrication tag, as the workman is now doing. The tag is a reminder that the turbine must be lubricated prior to operation. Your final step on any job should be to clean up your tools and your work area. Follow good housekeeping procedures, as outlined by your plant. As you have seen over the past few hours, the disassembly, repair, and reassembly of a typical steam turbine can be a time-consuming and difficult procedure. It requires concentration and knowledge of the turbine you are working on. Although the procedure we have shown you will vary somewhat for various turbines, you'll find that most of the steps will remain the same. If you have any questions, consult your manufacturer's manual and your supervisor. We have some questions for you now on the reassembly of a turbine. You'll find them in exercise number 5 in your workbook.